Hey everyone, welcome back to a new lesson with Learn Math by Example. Have you ever wondered how architects ensure that every part of a complex structure fits together perfectly, or how patterns in nature can be precisely modeled? Today, we're going to tackle an interesting construction challenge that will introduce us to the power of arithmetic sequences. But first, let's take a quick look at what we'll be covering in this video. Our journey begins with understanding some fundamental definitions, and then we'll go straight into solving the grand arc construction problem. Imagine building a magnificent archway. The first support pillar is 10 meters tall, but there is a catch. Due to the arc's unique design, each subsequent pillar must be exactly 1.5 meters shorter than the one before it. If the shortest pillar allowed in the design is 1 meter tall, how many pillars can actually be constructed to meet these precise specifications? And what would be the height of the fifth pillar? This isn't just a math problem, it's a real world design puzzle. Let's break down the core concepts we'll need. First, what exactly is an arithmetic sequence? Simply, it's a sequence of numbers where the difference between consecutive terms is constant. For example, in the sequence 2, 5, 8, 11, 14, you can see that each term is obtained by adding 3 to the previous term. This constant difference is what makes an arithmetic sequence. Next, let's define two crucial components: the first term and the common difference. The first term, often denoted by U1 or sometimes just A, is simply the starting value of your sequence. The common difference, denoted by D, is that constant value you add to any term to get to the next one. You can find D by subtracting any terms from its succeeding term. For instance, you can use un minus 1. For example, I can say u3 minus u2. This will give me D. u2 minus u1. This will give me also D. And here's a crucial piece of information for your IB exams. The general formula for the nth term of an arithmetic sequence, un is equal to u1 plus n minus 1 multiplied by d, is provided in your formula booklet. So make sure you know how to use it. Finally, the common difference d also tells us if the sequence is increasing or decreasing. So if d is greater than 0, this means that the sequence is increasing. And if d is smaller than 0, this means that the sequence is decreasing. 3, 7, 11, etc., it's an increasing sequence, while 15, 10, 5 is a decreasing sequence where d is minus 5. Now, a quick exam tip: when solving word problems, pay close attention to the language, like shorter, decreasing, or loses. All of these, they are strong indicators that your common difference d will be negative. So be careful when you read the word problems. Now that we have our definitions, let's put them to use and solve the grand arc construction problem. First, let's identify what we're given. You always start with the given. The first pillar is 10 meters, so our first term, u1, is 10. Each subsequent pillar is 1.5 meters shorter. This tells us our common difference d is minus 1.5 because here we have shorter, because the height is decreasing. And remember, the negative sign is important. If you miss it, then you will get incorrect answers. For part A, we need to find the height of the fifth pillar. This means we are looking for U5. Now we're going to use the formula. Un is equal to U1 plus n minus 1 times D. Substituting our values, you get U5 equal to 10 plus 5 minus 1 multiplied by minus 1.5. This will give us the height of the fifth pillar is u5 equal to 4 meters. For part B, we need to find out how many pillars can be constructed if the shortest required pillar is 1 meter tall. Here, we know that the nth term is un equal to 1, and we need to find n. Again, using our formula, un is equal to u1 plus n minus 1d, and substituting the values in it, we get n minus 1 equal to 6, which simplifies to n equal to 7. You are solving just a linear equation, as easy as that. So to meet the design specifications, we need 7 pillars, with the last pillar being exactly 1 meter tall. And the fifth one, as we calculated, would be 4 meters tall. Now, you see how applying the arithmetic sequence formula allows us to precisely model and solve this construction challenge. To get more practice, you can visit our lesson post and check the additional exercises there. The link is in the description below. Don't forget, discussion is a crucial part of learning. So if you have any questions or comments, feel free to leave them below. We'll reply to them as soon as possible. Join us in the next lesson for more exercises about arithmetic sequence. Thank you for watching. See you next time.